Now in this tutorial I want to show you two alternatives to the chi-square test for categorical variables, and those are the g-tests. So we're going to have a g-test for goodness of fit and we're going to have a g-test of independence. So the goodness of fit test, just like the chi-square goodness of fit test, we're going to have a single categorical variable and we count how many of each of the sample space values occur and we compare that to what we expect. And then in the independence test, we're just going to take two categorical variables and we're going to compare them to each other and see if they are independent of each other. So not a lot of difference. There's a difference, of course, in the equation that we use to calculate the g-statistic. So let's have a look at the g-test for goodness of fit and the g-test for independence. So in this short video, let's have a look at these g-tests for categorical variables. So what we're going to have to do is just import a library, Desk Tools. If you haven't installed it, please install that package, and then we import it with the library Desk Tools. So the g-tests, they are, as I mentioned, they are, well, we could replace the chi-square test of goodness of fit and the chi-square test of independence with these. So let's just first have a look at the g-test of the goodness of fit. And I just want to go down when we look at the g-test of independence just to show you what the equation looks like. So we're going to have this g-statistic. So again, we're going to calculate the statistic. That's going to give us a probability density function. It forms a curve and we can work out the area under the curve to give us a p-value. So it's 2 times the sum of this each observed value times the natural log of this ratio of observed to expected. And we calculate that for each value. We sum all of them up and we multiply by 2. So let's first have a look at the g-test of goodness of fit. So as with the chi-square test of goodness of fit, we have a single variable, categorical, or if we just use discrete values, discrete numerical, and we're just interested in the counts, not the actual values, we can use this as well. So imagine that we have observed 175 values. So just a simple example, for one of 2 unique sample space data point values for variable and 190 for another. We'll just have this imaginary little experiment and we collect the data. The sample space for this categorical variable has 2 values in it and we count 175 of 190 of the other. But what we expect, let's imagine we expected a 50-50 split. How can we use the g-test of goodness of fit to see if this distribution we found, 175 versus 90, is that statistically significant from a 50-50 split? So observed, I'm just going to create a vector there of 175 and 90, and the Desk Tools has a nice little function, g-test, as you can see here. X equals just your observed table, p is what you expected, a vector of 0.5 and 0.05. We're not interested in any corrections here, and that's going to give us this log likelihood ratio goodness of fit test. We see the g-statistic there of 0.6, chi-squared degrees of freedom of 1, and we see a p-value of 0.4. So that's not statistically significant from what we expected, a 50-50 split. Now, with the test of independence, that's the exact same as the chi-square test of independence, except that we use the g-statistic instead of a chi-square statistic. And if you watch that video, you can just have a quick look. We're using exactly the same scenario where we have the patients in group 1 and 2 and those that worsened stayed the same or improved. So exactly the same. Just to show you, we only have to create this little matrix with the rbind function. And then just to show you, the g-test is in the Desk Tools library. Don't have to put that, you can only put g-tests, the observed table there, and no corrections. And again, we get back our log likelihood ratio g-test of independence without correction. We see a g-statistic there, a chi-squared degrees of freedom being 2, and a p-value of 0.01. So again, a significant difference. So not that different from the chi-squared distribution. So there's your alternative using the g-distribution, the g-tests for categorical variables. Remember that for these tutorials on R, that the actual HTML rendered files are on RPubs, and that's what you might see on the screen. But these files are also available in their raw form on GitHub, and all the links will be in the description below. So you can either go to the website and look at the RPubs files as they're already rendered, or you can go to GitHub and download those files into your system so that you can use them in RStudio yourself. So if you like these videos on R, please let me know so that I can make more of these, or there's subjects that you want me to cover as far as biostatistics is concerned and the use of R, please let me know. Otherwise, please always remember to subscribe and hit the notification bell so that when new videos come out, you will know about it. You can also follow me on Twitter because that's where you'll also see that new videos are out.